Hello, everyone. Thanks for coming. Today we're going to show a little bit briefly about what we're doing with models or decisioning as a platform at Capital One. I'll sort of give you a high-level overview, and then Sumit, I'll toss it to him, and he'll get into some of the componentry and the architecture a bit. So this is this isn't working. There we go. That's who we are. We've already been through that. So level set and what we're doing. Again, we're going to give you an overview of what we're doing from a high level. We'll certainly answer your questions later. We'll do a little deeper dive in the architecture, some of the componentry we do, some of it will be familiar, how we use it from day to day, and then sort of wrap it up with the overall benefits that we're getting as a result of this stack, this platform, and our whole approach. So what's the need? So years ago at Capital One, we had, this isn't working. Is this battery dead? There we go. Okay. So, yeah, sorry. So years ago, our approach for data scientists or machine learning in general was sort of diffused across all the teams and sort of federated into the various tech teams, and it cross-cut a lot of our sort of domains, and it's when it comes to like fraud and marketing and different product ownership boundaries and so forth. And so we had this sort of federation of that. And at the time, our data scientists were essentially embedded with tech teams, so they're like hand in glove, working with them side by side. But not really on the same level. And by that, I mean, everything they had to do from the day-to-day standpoint when it came to productionizing their models was highly dependent on the tech teams. They really couldn't move anywhere without them. And so we found out that, oops, did I go too far? I did, I'm sorry. Yeah. So that was really tough. And what it ended up doing is, they'd throw models over the fence. Tech teams would take the model, sort of bake it into the app, and then deploy it. And that whole process would rinse and repeat. Anytime we needed to do a quick change, fast turnaround, it was a very laborious process, multiple steps, a lot of CI/CD, background that had to be sort of accounted for. We had a lot of auditing. We were highly regulated, and so you just can't pivot as quickly as you'd like. So some of these model development periods could be measured in weeks or even months. So it's really the time to market was really slow. So eventually, we had data scientists who were essentially coupled with not just with the teams, but the artifacts that they deploy were sort of lost, almost like in a layered onion in these products. And so we saw that as sort of a watershed moment. We wanted to kind of level the playing field with our data scientists and sort of give them the tools to do the sort of things that they can do alongside the engineers to be independent. Hopefully this switches. Sorry. There we go. So how do we do that? So we came up with this site, we basically pivoted. We figured, well, why don't we do models as a service? Take the approach of a microservices architecture for starters, get all the benefits we get of that at cloud scale, make it simple. I think self-service was sort of our mantra from the beginning. You shouldn't require a bunch of training and understanding of things like Docker and Kubernetes and cloud environments and so forth. So tooling was necessary, as well as being polyglot. So we have, depending on which team organization you're in, we have data scientists that do a lot with Python. We have others that build stuff in H2O, Mojos, Pojos, and so forth. So we wanted to support it all, be completely independent of that, and then give the ability to the data scientists to do what they need to do without sort of slacking a tech team or sending out emails or working through some schedule. Oh, and by the way, sorry, I'll back it up for a second. The red line, just to be clear, to level set here, we only do everything in the red line is what we decided to do. We didn't want to bite off more than we can chew. So, for example, notably, model training fell outside of our purview. So what we ended up doing is building sort of a cloud environment that sort of cut across dev, QA, prod. It does all the various different steps along our system. And of course, we have very CI/CD expectations, containerization, model servicing, inferencing, microservices. A lot of it's all 100% automated. And at the same time, we have that sort of governance, risk compliance layer on top of that. So the idea was to essentially empower our data scientists, give them that sort of democratize them, if you will, allow them to do the self-service model deployment and sort of take a hand in the whole operationalization rather than, again, tossing models over the fence and kind of being beholden to another team. Some of the net effects that we found was like model reuse, being able to sort of have one team produce a model that other teams might have thought about building, but they can use or share. We can also ensemble them, compose them, all sorts of different things. They wouldn't require code changes, and particularly even with isolated tech teams sort of doing their own thing in their own little silos. So this sort of made it a level playing field in that regard too. And then from the support standpoint, when it comes to invocation of inferencing, being able to do some more advanced, more sophisticated things without repeating all that development, such as champion challenger, multi-arm bandit, things like that. So, and then lastly, taking into account sort of the enterprise services that are already available to, like training, which we avoided because we had a very good training environment, and sort of integrating with that was also part of it. So to sort of widen the aperture on what it is we do, models as a service, or MAS as we call it, it's actually one of a few different sister services. They're all highly complementary. Notably, the features as a service is one that we use heavily. And so together we can it allows us to sort of do pass-by-value invocation or pass-by-reference invocation of service calls. So that's very nice. It's also sort of our clearinghouse of features, which allows us to search, support them, cache them, and so forth. So, and then lastly, we have a rule service as well. We won't talk about it today, but it allows us to do sort of Lambda functional type of business rules that sort of tie all of them together, if you wish. And then tooling, of course, lots of tooling. Wouldn't be able to do any of this without tooling. And again, keep it really simple. So with that, I will toss it over to Sumit. And he's going to talk about the architecture and some of the componentry to give you a little deeper view into what we're doing.
Yeah, all right. Thank you, John.
Yep.
So before I talk about the architecture, I would like to show this slide. This slide you've seen is shown in several data science journals that illustrates the reality of building a real-world end-to-end machine learning system. The black box in the center is the actual machine learning code, and all the surrounding pieces, relative in size, are the elements you need to have a successful end-to-end use case. Now we can divide into two phases: the model building that deals with the feature engineering, model training, and model development. And on the right is the model serving piece, which deals with the deployment, hosting, and invocation of the models. So in our presentation, Model as Service, we are focused on the elements on the right-hand side. So what are the pieces of a model serving, right? As you can see, there are like several things involved. Once a data scientist has built the models, you want to validate them, version, audit, and distribute them. We need all the familiar tooling like logging, dashboards, robust CI/CD, all of these in addition to serving your models. And you also want to think about resiliency and failover. How do you build activeness? Are you able to identify failures in a model and roll back to a previous version? And the last major challenge is capacity planning. So training is resource intensive itself, but also during model execution, you want to make sure that the models can scale and resources are provided automatically at runtime. And finally, we need to meet model governance and risk requirements. But based on the empathy research from data scientists, what we've seen is that we want to make it easier for the whole model deployment process and make it portable. By portable, what I mean is to make it easy to move a model from a data scientist's local environment into production, into staging or test clusters, and finally to production with all the controls in place. Let's see. I think this is out of battery. OK. So I might just stand over here, so to avoid this one. So keeping all these factors in mind, we wanted to build a system that gives us composability, that allows us to build modular components using a service-based approach. And this is a sample architecture, and this is how model as a service fits in our overall ecosystem. The model as a service components are shown in red. Starting with the model deployment service, this allows the producer to publish the models and deals with the deployment automation aspects for it. The model serving component shown in the center, that's the primary component. We're using a technology called Charrington core over here. It essentially deploys your model and serves them as REST and gRPC endpoints. The model routing service allows consumers to run predictions in the model. It's basically an adapter or abstracts out the underlying technology so you can use it, switch it with other platforms if needed. And finally, the analytics publisher service publishes all model metrics and can telemetry to a time series analytics database for dashboards and proprietary monitoring. The other components, as John has mentioned, are like the metadata registry that does the auditing, traceability, and discovery of the models, and also features a service and rules as a service. So let's say, for example, you have a transaction coming in. And before you score the model, you want to pull in additional features, some features as a service, invoke a model, and based on the model output, let's say for the score, run a rule with an output to invoke an operations team, for example, a fraud operations team. So you can build any combinations of decisioning use cases using these three services. But the mindset here is, instead of dealing large monolithic applications, you write small single-purpose functions that are invoked by events. So I talked about the centerpiece, which is the model serving component. We use a technology called Charrington core. Charrington core is an open source platform for deploying machine learning models. It supports a polyglot of model technologies and is built natively on Kubernetes. And once your model is saved, you can package the dependencies into a container and run them as self-contained atomic units. And Kubernetes, as you know, is the market leader in terms of providing container orchestration. It takes away a lot of pain from DevOps by providing easy control deployments and scaling up large, complex applications. And with Kubernetes, you can leverage all the benefits like scaling, fault tolerance, resiliency, blue-green deployments, rolling updates, and isolation all out of the box. So these are all the high-level steps. I'll briefly skip over through this. But essentially, Selden gives you your models to be served as REST and gRPC endpoints. And Selden not only does single model deployments, you can have multiple model deployments and do things like A/B testing or multi-app bandits. You can combine the outputs from several models and return an average score for better predictive performance. And then transformers allow you to do feature normalization, transforming the request and response, and outlier detection. And Selden code is actually also used in several popular frameworks like kubeflow and Fabric for deep learning. So I'll go through quickly each of the microservices that we have, starting with the model deployment service. As I said, this allows a producer to provision the model. These are the components to build it out in a Kubernetes cluster running in a popular cloud provider. And in order to access this service from outside the cluster, we have the API gateway that forwards a request, the model deployment request, to the Route 50 entry that points to our Elastic Load Balancer, and then a Kubernetes ingress resource maps that DNS entry to backend service. The backend service then takes over, validates a manifest file, makes a call to the common platform services. For example, authenticate the request, publish the model information metadata, and then it invokes the CI/CD pipeline, which I'll cover next. And that essentially sends a request to Selden. The Selden operator then receives the request and then pulls the containerized model image and creates underlying resources, creates underlying Kubernetes resources like deployments, pods, config maps, replica sets, and services to expose your model. So let's see what the experience from a data scientist point of view. The data scientist would essentially start by building the model. Let's say this is an H2O model that he would check into his repository, and also provide a test.csv or test.json file. This test.csv file contains the feature names as the header, and subsequent rows are the feature values. Next, they would prepare. They would also version and tag this repository. Now, this is an example using Git, but you can use other open source tools like ModelDB, which is another talk happening exactly at the same time. So once they've tagged and versioned it, they would prepare this model manifest file. Now, this is what contains the information about your model: the model name, the model location, where your test is, the model type, so you can package and containerize the format, all the model dependencies. So all those are injected at runtime by a model. And finally, they would invoke this post API. Since it's all service-based, they would invoke this curl command. The model deployer service takes over, validates the request, and sends them a 201 accepted request saying that your model deployment is in progress, and wait for an email notification. What happens in the background is the CI/CD process gets kicked off. Now, in order to be well managed, you want to follow the control gates of your organization. So the CI/CD does things like static code analysis, security checks, and then it packages the model in a Docker container format, and then prepares the Selden deployment request and submits the job to Kubernetes API for deployment. We also care about doing blue-green deployments. So the model is tested before it's actually published. The test results that are used that are given by data scientists are actually injected to the model before we notify the data scientist. The test results are also saved for further promoting this model to production through another approval process when needed. So this test basically essentially builds the trust in our delivery pipeline. But the overall goal here is to have a repeatable pipeline to make model deployments easier and iterate faster. So this is an example of notifications that go out. We have the Slack notifications that contains the REST endpoint and the Swagger docs. And then in the email notification, we attach the model test results for accountability. Now, this basically ensures that for the input data that the data scientist provided, the model ran successfully, and the model scores and output that it produced are verified by data scientists. So this model output test.csv also contains the model results and the model execution time. The second microservice is the model routing service. every request comes through this model routing service. This microservice essentially takes the payload with the list of features and values, runs the prediction in the model, and responds back with the outputs in a request-response manner. This model routing service also interacts with other services, like the platform needs for logging, auditing, and also pulling additional features when needed. And in addition to the offerings by Sheldon, for example, A/B testing and multi-M bandits, it also extends the capability by adding new features like champion challenger functionality. So you want to expose your multiple ways. You want to have multiple ways to interact with the model services. So this is a REST request and response. On the left, as you see, contains the feature names and values. You can even micro-batch it if you needed to, and the feature values can contain a reference to the features hosted in a feature as a service part. So the response contains the model outputs and the model labels that can be overridden that contains the model scores in this regression model, for example. And then if you want to have a faster, high throughput application with low latency, you would use a gRPC-based protocol. So this is an example of a gRPC client done in Python. For model testing, now this was important because we wanted a way for a data scientist to test a model offline and independently without knowing all the details on how to construct the payload format, whether it's REST or gRPC. So here's one way. We provided the Python library that's sort of an SDK that can be used in the CLI or the Python notebook, and essentially converts the CSV or into the right format, invokes the model, and responds back the results in the notebook. So the data scientist is completely unaware of the underlying implementation. And also, we have support for data frames. Now, data frames are the most commonly used pandas object. The data scientists usually like to slice and dice the data before invoking in models. So having all this integrated in the notebook is also a big plus. So dashboards and metrics. So out of the box, we provide some basic dashboards. For example, like the top 10 model executed in terms of duration, the rate of model invocation with success and failures, the average model execution time, number of features pulled, etc. So we also are allowing the data scientists to build their own monitoring so that we give the capability to data scientists to log all the metrics, and that gets pushed off, and they can build their own dashboards when needed. And for engineering teams, like if you want to have more detailed analysis, how your model is performing, what the microservice is doing, for example, how much time is it taking to pull in additional features and the time taken to execute the model. So these are application performance metrics that also provided as a part of our service. In order to make the onboarding easy and seamless, it's an API-based specification. The API, the gateway does things like authentication, rate limiting if needed. And on the left-hand side, what you see is the model deployment API, the standard CRUD operations to create, read, update, and delete your models. And the right-hand side is an example for the prediction API. But you can also have other APIs to do like A/B testing, run A/B testing campaigns, and or even gather runtime analytics in a champion challenger mode. So with that, I'm going to hand it over to John, and he's going to talk about how this impacts our organization.
Well, so to wrap up, I mean, we went through a lot at you guys, but to wrap up, I mean, what we ended up with the seamless onboarding experience, very self-service, totally empowering and enabling. That was the whole goal from the beginning, not requiring tech teams and so forth. And then being resilient and scale at web scale, effectively, having the same sort of, enjoying the same benefits that a tech team would from their own microservices or whatever it is they're deploying. And then some of the other incidental effects that we get of this is, again, I mentioned this before, model reuse, time to market's reduced, and different types of invocation strategies. You can sort of toggle on and off without having to go through a redeployment phase. So that's that. What's the next slide? I don't have the clicker.
Yeah.
And that basically is our talk. Thank you all for listening to us. It was a little rapid fire there, but and that's if you need to contact us, definitely come see us afterward, and we'll chat. So, thank you.
Yeah. Thanks for having me.
Cool.
Yeah.
Lunchtime?
We have a minute for Q&A.
Yes, we have 5 more minutes. Oh. Thank you, John and Sumit, for taking us through model as a platform journey at Capital One. So if anyone of you have questions. Yeah.
Sorry, I'm on the first row, so I'm going to take advantage of it. Yeah, asking a question about the feature as a service.
Sure.
So I wonder, what's your view of a feature as a service or feature store versus your relationship with your data lake? I mean, eventually the feature came out from your data, And do you see them separate or do you put them all together? It's more of a high-level question.
I can take that. So the features of service, we should be a little more clear. So it's not an end-to-end feature engineering, all-encompassing sort of service. It's more of a facilitator. It's sort of surfacing features. We have a lot of expectations for SLAs being very small, very tiny sub-second latency budgets that we don't want to break. For those types of applications, it's basically, you can look at it as a glorified, I don't know, L1, L2 type caching mechanism. So the expectation is feature calculators, other feature engineering pipelines outside of our ecosystem are publishing those features to us, and they could come from a lake, they can come from a EDW, whatever. But then we make the guarantee that it's versioned, it's always available and highly available in that regard, and that we have the ability to, when we call a model, the vectors you were showing earlier, you could have some proportion of those having references that we intercept right before we call the model, and we actually grab those features and interpolate them and then call the model. So you don't actually have to package everything in every single payload. You could say, maybe my app, or maybe it's customer facing, I only have certain bits of data, but I want to get those features fast, we'll provide that last mile bit. But that, as far as how they got there, that's sort of outside of the scope of the FAS as we know it today. Yeah, but what you're describing is, a lot of that goes on, so it makes sense. So,
yeah, good question. So there's exactly a talk happening at this time at Boston by two of our engineers, and they're talking about our feature as a service.
Yeah, we're dividing and conquering the country, so we sent them north, we came down out here, so.
Yes, yeah.
Obviously, latency is really important.
Yeah.
Yes.
You've got, and this is handling all kinds of applications at Capital One.
Oh yeah, marketing, fraud, cyber, yeah.
Website recommendations, that sort of thing also.
Yeah.
In those cases, obviously both latency and TPS is really important because the application might be requiring that many models be kicked off at one time to make a decision.
Sure.
Can you comment on the scalability problems that you might have?
Well, I mean, I think you touched on sort of a self-answering question. There's a lot of those things those factors we have to take into account, and it will range. Not all of our users require that sort of latency. Some of them can be measured in seconds. Some much less than that, and so it just depends. A lot of that, I guess the users inform us as to how we adopt from a deployment standpoint. So do we need a dedicated cluster? Do we need to have a larger ALB or whatever? So like a lot of those things they go part and parcel with the deployment mechanisms for our platform, so we can, the care and feeding of it. But it does run the gamut of those types of domains. It is multi-domain. We don't really like to care. We want it to be essentially black boxes that we run, but at the same time, meet the SLAs, the QoS type of expectations that they have. And that's one of the challenges that's ongoing for us. Like, I don't think it's ever going to be done. We're going to have to constantly stay involved and make sure that we're doing the right thing there. But it's a good question. Yeah.
We have 2 more minutes if anyone else has the questions.
Wow, I love that.
This one.
Yeah, thanks for the talk. I wanted to ask about the feature service. How do you sort of police and enforce what's available at serving time versus what might be available at training time?
So
again,
we kind of absolve ourselves of the responsibility of what is actually, so it's basically the latest and greatest is always the only recommendation or expectation we can give. So those who sort of that generate the features or manage them, and by the way, it's varied. There's so many different approaches in a company this large. So we didn't want to be prescriptive because we would never win that battle. So what we did was we provided a microservices approach for them to sort of push their data in there, specifically features. And we have a couple different ways. You can throw it into an object store, and we surface that like nightly or periodically. Or you could have something that requires something to be more intraday, so they can use the API and publish it. But the expectation is we're not the publishers of the data per se, and that whoever did the publishing to us is authoritative for that. And so when it comes to making sure the data is well managed, it's not lost, it's versioned, it's secured, all those things, we're kind of pushing that out to them. And when we get it, it's essentially a copy. In other words, we could pull the plug on the entire feature system and then plug it back in, and then it would just recompensate from stuff that was already stored elsewhere. So we're kind of cheating a little bit. We're not taking on the entire responsibility.
So do they do the quality monitoring of that
Yeah,
data?
QC checks, that kind of stuff. We're expecting that's already been done.
Yeah.
So.
And the feature ecosystem is all available through the same REST-based API approach. You can query them, the features available.
Yeah, the metadata service he touched on earlier lets you search them. It's almost like a Google appliance for all of our features. But how they got there, that's a whole, again, that's outside of the scope of what we do.